Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also during today's webinar, we do have 3 polling questions, so please keep an eye out for those and hopefully we'll get your answers. And also at the end of today's webinar, we are going to be doing a drawing for 4 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is a cloud native data protection for Kubernetes and Red Hat OpenShift, TrilioVault for Kubernetes. Our speaker today is Prashanto Kokavara, who is the Director of Product for Kubernetes at Trilio. Prashanto, thank you so much for joining me today. Really appreciate it.
Thank you, Charlene. Happy to be here.
Great, great. Well, I'm going to put myself on mute because I know you've got a great presentation. I'll just let you get right to it.
Great. Thank you so much. And yes, let's kick it off. So good morning, good afternoon, good evening, everyone, wherever you are connecting in from. My name is Prashanto Kokavara. I am the Director of Product for Kubernetes at Trilio. And today I'm going to be introducing TrilioVault for Kubernetes, which is a cloud-native data protection solution for Kubernetes environments. And as part of this presentation, I'm going to be going over or introducing the product, talking about the architecture, functionality, use cases, and overall compatibility. We have a pretty packed agenda today. As part of the agenda, I will be talking about Trilio as a company, who we are. We will be discussing the customer problem as to why this solution is needed today by looking over legacy data protection solutions versus cloud native applications. After that, we will be talking about TrilioVault for Kubernetes, the product, an overview, giving you a high-level understanding of what the product provides to you. Then we will get into the technical details of TrilioVault for Kubernetes as to how we do the backups and restore operations in general. We also have a demo that we can leverage and we will be using to show you guys how TrilioVault for Kubernetes can back up and restore Helm-based applications. And finally, we will wrap it all up with a summary of the overall presentation today. So jumping right in, let's talk about the company. So Trilio was founded in 2013. We already are the leading platform for data protection in Red Hat virtualization and Red Hat OpenStack environments in general. We have customers present all over the globe. We have our employees spread all across the globe, and we are backed by leading venture capitalists and tech luminaries. All our technology that we're going to be talking about today and across the other products have been patented, and we stand firmly behind it. We have a very strong global partner ecosystem, as you can see on the screen. And then very importantly, we are a Red Hat certified partner as well. So the net over here, what we want all of you to understand that Trilio has been in the business doing data protection for a while, and we understand the space with Kubernetes, Red Hat pretty well. Now let's jump into the customer challenge. But before talking about the challenges, I would like to understand from the audience as to what type of applications do you run in your container environment today? Obviously, they could be stateless, stateful, or it could be a combination of both. So if you could help me understand this as we move along the presentation, that would be great.
Okay, we'll go ahead and give you guys a couple seconds to make your choices. The poll should be right up on your screen, so go ahead and choose from stateless, stateful, or both. And while we're doing this, I do want to remind the audience that at any time during the presentation, if you have a question for Prashanto, please go ahead and use your GoToWebinar control panel and go ahead and get your questions in, and we'll try to get to as many as we can near the end of today's webinar. Okay, we'll go ahead and give you guys a couple seconds more and then we'll close it out. Prashanto, do you want me to push out the results to the audience once the poll has been finished?
Yes, please.
Okay, all right, great. So I'll go ahead and do that now. I'm going to go ahead and close the poll, and here are the results. Wow, that's interesting. Both stateless and stateful folks, majority of folks are running both of them. That's awesome.
Exactly. So if we kind of look at how the container realm or the container hype had started, everything started with the idea that you would be running a lot of stateless applications. But over time, what we have seen is that customers have begun to run a lot of stateful applications, and they're running a combination of stateless, stateful, and both of which need to be backed up or protected in some form or another.
Interesting. Well, I'm going to go ahead and hide these results and let you get back to your presentation.
Thank you. Okay. So now that I understand better as to what everyone is running in your environment, which aligns with what we have been seeing in the market in general, I'm going to talk about the evolution of applications, which is going to be a good introduction as to why a cloud-native data protection solution is needed. So I'm going to build out the slide, and the way I'm going to discuss this is the architecture of the application has changed significantly from virtualization to cloud native, right? When we look at the architecture of the application for bare metal environments, you had these tightly integrated components which were working together within a isolated domain like an operating system and providing some service. Now, obviously, you could have had 2-tier and 3-tier applications which could be running in multiple servers, but in the end, the application composition was still tightly integrated components all working together. When you move to the virtualization realm, what you see is that the architecture of the application was still the same, but you were able to deploy a lot more of these applications, a lot more instances of these applications to get better utilization of your underlying hardware. But overall, the architecture was still the same, tightly integrated components, all interacting with each other within a isolated domain. Now, with cloud native applications, as you can see, your application can be built or comprised of independent microservices. These microservices have their own identities. Each microservice could be connected to a volume on which your data is residing. So now, in order to protect an application, whether it was on bare metal or whether it was cloud native, is completely different, because not only do you need to understand each and every microservice that is running, but you need to also understand and capture how these independent microservices are working with each other. What are the security policies, or what is the plumbing work that has been done to ensure that these microservices or containers run in that environment successfully? So in order to be able to bring up your application after a backup, it is important to have this metadata information in order to bring it up quickly, efficiently, and successfully. And diving more into the traditional data protection technology, we know that now that we see that these are two disparate technologies, cloud native applications and the traditional data protection, which focuses more on siloed monolithic applications. They focus a lot on applications that are not changing footprint that often. And when you look at the cloud native side or containers, we have applications which are being scaled up, down, on demand very frequently. Traditional data protection technologies are also focused more on the storage or the data volumes, because as we mentioned, right, when you have this application, when you deploy the application, most of the pieces around the application are already tightly integrated and coupled and are provided to you right off the bat. So you do not need to worry about those pieces, and these legacy technologies focus on the data portion of it. But on the cloud native side, because of these independent microservices and the connection and the communication between them and how they fit together is very important to capture, because that becomes the overall architecture or the overall DNA of the application. And then lastly, traditional data protection technologies, if we look at them, they've been kind of architected from the IT admin's point of view. But when we look at cloud native environments, it is bringing the DevOps utopia closer, right? You want to get more synergy between your developers and your IT administrators by giving them the same technology that can be leveraged by different users based on roles and permissions. So in a nutshell, we can see that traditional data protection technologies are not going to be able to capture the cloud native applications successfully, and are not going to be able to fit into the principles and the methodologies that Kubernetes and cloud native environments have put forth to make application modernization possible. With that, I'm going to now introduce TrilioVault for Kubernetes. And before doing that, I have another poll question for all of you, which is in terms of the Kubernetes distribution. So I would like to understand what is the Kubernetes distribution that everyone's using today? Is it Red Hat OpenShift? Is it any other upstream distribution like AKS, GKE, EKS, which are in public clouds, or if it's SUSE Container as a Service, PKS, or any other distribution, which could still be a combination of both?
All right, well, everybody is going ahead and making their decision. Just another quick reminder that anytime you have a question, go ahead and use that GoToWebinar control panel to submit your questions. I'll give you guys about 15 seconds more, and then we'll go ahead and close this polling question out, and we'll take a look at the responses. All right, let's go ahead and close this one out. Take a look at the results here. Looks like the majority of folks are using the other upstream distributions.
Correct. So it seems like we have almost 80% of folks using that at OpenShift and upstream distributions. So which means that, which is great, because as part of the product, which I'm going to be introducing on the next slide, this wraps in very well with what we have been doing or what we have been working on, how we are targeting the market today.
Excellent, excellent. Well, I'll go ahead and hide the results and let you get back to it.
Okay, so I'm going to be talking about TrilioVault for Kubernetes, and before getting into the meat of it, I'm going to talk about the DNA for data protection that Trilio uses. So one of the first items here is that we believe in making our technologies completely agentless. Whether it was a virtual machine technology or container technology, we do not believe in adding an agent into the application or the virtual machine, or injecting sidecars into pods for capturing data or for doing any kind of data protection. We believe in making our product multi-cluster, multi-tenant. We want to make sure that any kind of user can use the application based on their roles and permissions and privileges. We also believe in self-service UI integrated technologies. So wherever we can, we try to integrate with the distribution platform to ensure that they can get the best out of their infrastructure through a single pane of glass. We also believe in, and we ensure that our products are scalable, linear, and can reach infinite scale in terms of data protection capabilities. We are completely non-disruptive, so you continue to use your environment the way you have been using it by installing Trilio and doing your data protection pieces without even changing anything else in your environment. And then finally, we put a strong emphasis on an open universal backup schema There are several reasons for this, whether it's a hybrid cloud topology that you are focusing on. We want to make it easier for you to port your data between those two environments, or if it's a public private cloud kind of a hybrid topology that you're using, you can easily scale or move your data from one environment to another. This also opens up possibilities for doing additional workflows on top of the data, such as vulnerability scanning and so on. And with that, I'm super proud and excited to be presenting TrilioVault for Kubernetes. I'm going to be going in a circular fashion, talking about our product. I'm going to start off from the certified technology on the left. So firstly, TrilioVault for Kubernetes is a certified technology. It is certified by Red Hat and IBM Cloud Pak for data and management. We are available directly within Operator Hub. We did our GA launch last Friday, and the 1.0 version is available directly for installation from Operator Hub within OpenShift. From an infrastructure compatibility perspective, we leverage CSI, which is the de facto framework interface for communicating with storage from a Kubernetes environment. So regardless of the backend storage that you're using, in any kind of storage, you will be able to use TrilioVault for Kubernetes as long as you're using a CSI compatible driver. We provide two storage options to store your backup data. That is on an NFS file-based storage or an S3-based storage. The S3 storage could be Amazon S3 or can be an on-prem capable S3 device as well. And then because we have built the product in such a way, you can run it in any public or private cloud, whether it's the hyperscalers or in your own private data centers. Now, what we've done is the way we are backing up data is we are completely application-centric. So we focus on the application. We back up the data, persistent volumes that we were talking about, the metadata, which is the communication between different microservices, all the other nuances and pieces, objects that are needed to run your application successfully, and all other Kubernetes objects like secrets, services, deployments, all those pieces are also captured as part of the application, and that's what we focus on. We've built the entire platform native to Kubernetes and OpenShift. So basically, we are packaged up as an operator. We are deployed as multiple custom resource definitions, and we integrate completely into the Kube API server. What this means is that you do not need to learn anything new to manage Trilio as an application or manage Trilio as a software, because as long as you understand and you've been working with your Kubernetes means and ways of doing things, you will be able to use the same to do it or to manage and operate Trilio as software. And then finally, from an application deployment and ecosystem tooling perspective, I mentioned that we focus on applications. You will be able to back up applications, whether they are provisioned via Helm, whether they are operator-based applications, or they are custom label-based applications. And from an ecosystem integration perspective, we are directly integrating into Prometheus and Grafana, which are the de facto monitoring tools, and into Fluentd for logging as well. Now, the best of it, we have multiple ways to try out the product. We have demos and test drives available directly from our website, that's trilio.io, which we will share as part of this webinar in the end. You will have multiple scenarios that you can drive through without having to install the product in your own environment. And then you also have multiple licensing models. We have a 30-day free trial for unlimited number of nodes. You have a basic edition, which you can use for an unlimited amount of time, up to 10 nodes. And then you have an enterprise edition, which provides premium support for a custom number of nodes and a custom amount of time. So that's overall TrilioVault for Kubernetes in a nutshell, what we are providing. Next, I'm going to talk about the packaging and accessibility. So coming back to the previous poll question that we had, we saw that upstream environments or that our OpenShift environments made up 80% of the poll results. And what we've done is we've tuned the product to support any upstream Kubernetes environment or any OpenShift or operator lifecycle manager enabled environment. So we have packaged up our product as an operator. We have an upstream operator, which is deployable through Helm. It supports Helm v2 and v3 and deploys a CRD through which you manage the overall application. When we move on to the OpenShift side, OLM, that's the operator lifecycle manager, replaces our upstream operator, and it becomes our operator in general. And we integrate into OLM to provide our application, which is available directly through the embedded operator hub that I've already mentioned. So a quick look at how we do appear in Operator Hub. If you go to Operator, or if you go to the OpenShift console and on the left-hand side panel, go to Operator Hub, you search for Trilio, you will see the Trilio tile available. You install it. Once you install it, this is how we appear within the Operator Hub interface. And as I mentioned, we are a certified technology. We go through rigorous testing and validations every time we provide a piece of our software within Operator Hub. Okay, now we'll be getting into more of the technical details of the product. And as part of the technical details, the first thing I'm going to talk about is the architecture of TrilioVault for Kubernetes. So at the lowest or the most, at the first level of interaction, what we have are a bunch of custom resource definitions which are used to operate or manage the product. The user interacts with these custom resource definitions. I will be diving into what these custom resource definitions are in the following slide. But for now, for your understanding, at the base level, the user operates or interacts with our technology through CRDs. At the next level, we have the control plane. In the control plane, we have all the controllers which monitor the custom resource definitions and act upon it whenever there is a change that is noticed. And within the control plane, we also take care of the metadata backup of all the plumbing pieces that I had mentioned earlier. The third level, we have the data plane, which basically within which we do the backups of the persistent volumes. So within this layer, we actually snapshot your persistent volumes and do the copy transfer protocol into a NFS or a S3 target repository. We do this very efficiently by spinning up one data mover pod per persistent volume, and then we back it up into the target repo. For subsequent backups, we obviously use an incremental technology by, again, leveraging CSI to take a snapshot, and then we have our own mechanism to do a diff of the data and then back it up into the target. Now, coming to the custom resource definitions that I mentioned, we have a bunch of different custom resource definitions. The first one I'm going to talk about is the target. You use the target CRD to create a store where your backups are going to be placed. This can be either an NFS-based target or an S3-based target. We have a policy-based CRD in which you specify the frequency and the retention. You have hooks. Within hooks, you basically specify if there are custom injections that you want to do within a application to QS it for application consistency. And all these items, basically all these different CRDs are referenced in a larger CRD called as the backup plan. You can think of the backup plan as the overall objective of what you want to back up, how often you want to back up, and what kind of intricate injections or anything else you want to do as part of that overall backup. Within the backup plan, you can specify one application or it could be multiple applications. So it's up to the user to define what a backup plan looks like. It can be multiple applications talking to each other that you want to protect together. That can be a backup plan as well. And within the backup plan, you basically specify all your Helm applications, your label applications, and your operator-based applications. Then finally, you have the backup custom resource, which acts upon the backup plan CRD and backs up the entire application or whatever you have mentioned within the backup plan. And then on the other side, on an inverse, when you do a restore, we take the backup, we perform the restore on the backup, and then you get your application or all your applications as part of that restored back again. So this is at a high level how Trilio works, in terms of the backup and the overall restore process. Now, just to visualize what can happen as part of TrilioVault for Kubernetes, you can backup and restore within the same cluster. You can backup from one namespace and restore into another namespace, or you can move your applications and workloads from one cluster into another cluster. And this can be obviously everything is possible by hosting your backup data in the centralized repository, which can be NFS or S3 based. Okay, now just to get some more understanding of how everyone is using their applications and their technologies today, how does the audience today, how do you guys manage and deploy applications? Do you use operators? Do you use Helm, custom labels, or some combination of the above options?
All right, you should have the polling question up on your screen now. Go ahead and make your choice between operators, Helm, labels, or some combination of the above options. And then once we've had a healthy time to have everybody make their submission, we'll go ahead and push out the poll results. Meanwhile, I do want to remind you once again that we will have time for question and answer. So if you have a question for Prashanto, please go ahead and use your GoToWebinar control panel and submit it. And we'll give you guys I would say about 10 more seconds, then we'll go ahead and close this out. We'll take a look at the poll results here. All right, I'm gonna go ahead and close the poll now. And here are the results. Looks like combination is winning the day again. So.
Great. So it seems like some combination of labels, Helms, and operators, with a lot of weightage on Helm and operators, which is definitely great. And I'm pretty sure everyone's going to be excited in the next few slides that I'm going to be showing.
All right, there you go.
Okay, so what do we back up? So as we mentioned, we can do custom labels. We can back up your Helm application, and we can do your operator-based application as well. When we do custom labels, we look at the spec of that label-based resource, and anything within those label-based resources, pods, PVs, config maps, secrets, we back up all of those. If there are persistent volumes associated with that object or that resource, we back it up as well. Now, as part of your label selection of what you want to protect, you can have multiple labels. You can use set-based selection. You can base it on objective resources as well. So you can manipulate and protect any item that you want within your cluster technically through labels. The next item is Helm. So when we do a Helm backup, what we do is we back up all the revisions, including the deployed release of that Helm chart. We parse the chart, we look at all the PVs, and then we back up data for those PVs. Now, one of the most important parts to mention over here is that we maintain your application tooling consistency. So if you have a Helm application and you back it up and then you restore it, it is still a Helm application. When you do a Helm list, that restored application is still going to show up. Or if you do a Helm upgrade or a Helm rollback, and that is a key piece of value that Trilio provides of maintaining your application tooling consistency. On the operator side as well, what we end up doing is we back up not only your application resources, but your operator-based resources as well, so that when you restore this application, it is still an operator-based application and you use it the same way as you were using it before you took a backup. So that is what Trilio believes in. A backup and restore should be giving you exactly what you had before you were running or before you actually executed the backup operation. Okay, now getting into the workings of how Trilio does backup and restore, we have a few animated slides. I'm going to talk over how this animation works. So as part of the full backup, the first thing that Trilio does is we spin up a metamover pod, and this metamover pod is going to be doing all the backup of the metadata objects to the target in a JSON format. Okay, and the next thing we end up doing is we do a data backup. In order to do the data backup, we spin up a data mover pod. And in order to make this more efficient, what we do is we spin up one data mover pod for each persistent volume that we find. We create a persistent volume snapshot of that PV, leveraging CSI. The new PV, we connect it to the data mover pod. And then from that data mover pod, we move all the data and convert it into a QCOW2 format on the target. Then we detach the persistent volume from the data mover pod and we delete that persistent volume. But what we end up doing is we keep one of the snapshots behind, the most recent snapshot behind, because that is what we are going to use for our incremental backup. Now, on the incremental backup side, things flow the same way. We end up doing the metadata backup first by spinning up our metamover pod, which is going to capture all the metadata and then move it into the target location. And then once the metamover pod has done its job, we do the data backup. And the data backup, as mentioned before, is going to spin up the data mover pod, which is going to ask for snapshots of your persistent volume, leveraging CSI, convert those snapshots to new persistent volumes, connect those new persistent volumes to your data mover, calculate a diff or a delta between those volumes, move the incremental change to your target, and then finally detach the volumes that are not needed and do a incremental overlay of your QCOW2 image onto the base image. So what this also helps in is making sure that we are moving only incremental changes into your target repository. The QCOW2 image or the QCOW2 format also provides a lot of benefits in terms of deduplication, in terms of the amount of data that is being written, and the amount of data that is flowing over the wire as well. And then finally, again, we keep the last snapshot that was taken for the next incremental backup as well. Now, restore works the same way. It's an inverse of the backup process. And we have a slide which goes over the animation as well, similar to before. So let's say the user asked for the restore of one of his backups. We start off with a data restore. In order to do the data restore, we spin up the data mover pod first. After the data mover pod has been spun up, we restore the PV. There is no staging of the data. We directly restore it into a PV from the target location. And then we do a convert of that restored PV. We detach it from the data mover pod, and then we have our data volumes back. One of the questions that I do get on this slide generally is that how do we know how many PVs to restore? So what we end up doing is before a restore, we do a restore validation where we understand the number of PVs that need to be created directly by scanning the target environment or the target location. So once your data has been restored, that is the persistent volume, we restore your metadata, and the metadata is again converted back into your Kubernetes environment as Kubernetes resources. And then we connect your persistent volume to the metadata, which basically gets your application back to you. So now we've seen backup and restore, and as part of backup restore, there are multiple use cases that are enabled for your environment. So one is point-in-time recovery, backup and recovery of your applications on a scheduled basis or an on-demand basis. What we end up doing is full and incremental backups. One of the differentiated technologies, again, in terms of how we do the backups, is we have forever incremental backups, where we enable a lot of data efficiency in terms of the data that is being stored on the target repository. You can have cluster or namespace level restores, and you can have full or selective app restores as well. Next use case is disaster recovery. So in order to recreate your entire Kubernetes clusters from one site to another site, you can use TrilioVault to do that. The next one is application mobility or data management in general. If you think about it, backup plus restore in general is equal to a clone. So you can use TrilioVault for Kubernetes to clone your production environments to test environments, to development environments, and recreate those exact environments, and achieve operational efficiency in terms of time savings as part of your development process. And then finally, migration. We've spoken about hybrid cloud deployments, or hybrid cloud deployments where you have two hyperscalers, or if you have public and private cloud deployments. To reduce costs or improve security, you can use TrilioVault for Kubernetes to migrate your data in and out of one cloud to another cloud environment. Okay, next I'm going to talk about monitoring and logging. So what we've done is all metrics from TrilioVault for Kubernetes, we are automatically pushing them to Prometheus. So if you have a Prometheus instance running in your environment, you will automatically get all the metrics that Trilio is pushing directly from the Kubernetes cluster. What we are also doing is we have provided about 10 dashboards out of the box as part of the product, which makes reporting and analysis of your data protection landscape easier. These dashboards are pivoted in terms of your targets, your backups, your restores, and your applications. So for each of these pivots, we provide summary views, overview views, and detailed views. So very, very extensive reporting can be achieved through Grafana by leveraging these dashboards right out of the box. What we've also been working on is integration with FluentD. So all our logs will be integrated into FluentD, which is also one of the de facto tools that have been coming up and being leveraged a lot in Kubernetes environments. On this slide, we have a list of all the different metrics that we use for creating our Grafana dashboards. And as I mentioned, we provide these 10 dashboards out of the box, but customers are free to leverage these metrics and create their own visualizations and views and dashboards within Grafana as well. Okay, let's talk about security and permission of TrilioVault for Kubernetes. So one of the major things is we do not require or depend on any cluster admin roles or privileges. Which is big, because from a security standpoint, you do not want to give cluster admin role to any kind of application that is running, because it is a pretty important role which could compromise the security of other aspects of your container landscape. We leverage the security contexts provided by OpenShift or the pod security policies provided by upstream Kubernetes. We create our own service accounts and do not leverage any of the default service accounts. Our service accounts for operations are also created during runtime, so that adds additional layer or padding of security. We have our own set of permissions and capabilities, which we have documented extensively on our public documentation, which is available through docs.trilio.io. And then there are also security product definitions and a full product FAQ around security as to how we do certificate management, do we use TLS, do we do any kind of encryption of the data on in-flight or at rest. All that information is provided within the product definitions page as well. Okay, so with that, I'm going to move into a demo of Helm and a Helm application on OpenShift. The way I'm going to be presenting this demo, I'm going to be speaking over it. The demo is going to be run via CLI, but we'll be showing the details through the OpenShift user interface as well. So just to level set what we're going to be doing as part of this demo, we will be creating a Helm-based application. We'll make sure that that Helm application is running fine. Once the application has been created, we will be doing a backup and then a restore of that application, and we'll be visualizing that everything is up and running and everything is good to go as well as part of the overall process. Okay, so I'm going to start the demo now. So what we're doing here is first we are deploying our Helm-based application. We're going to do a Helm list to ensure that the application is up and available. We're going to look at the pods as well, look at the service, the replica sets, the persistent volumes, and then finally we will expose it to ensure that we have our app running and available. Now that our app is running, the next thing that we're going to be doing is doing a backup. To do a backup, the first thing that we end up doing is we want to ensure that we have a target that is available. And in this environment, we have a AWS S3 target that's created and available to host the backup. We execute the backup by applying a YAML file, and then we list all the protection templates that we have for the backup, and we will confirm everything by going to our OpenShift user interface. What you see in front of you is an OpenShift 4.2 interface. As mentioned before, we are available directly within the Operator Hub. And now what we'll do is we will validate that the backup operation was triggered off and we have a backup available within OpenShift. Going back to the terminal, we will be now initiating the full backup of the application. We will be listing the backup to ensure that the backup has been triggered off and there is some progress happening. And we can describe the backup to see what other items have been picked up as well. And then we can look at the backup job. We can see that the backup has been created and it is in progress. We can validate the details of the backup by running a get backup, and we see that the full backup completed. It's available now. And in order to move on with the next step, we will go into the namespace that we are going to be restoring this into, and first validate that there are no other objects or no applications already running over there. So first thing that we'll do is we'll apply the restore YAML file, and then we'll do a get on the restore to see that the restore operation has begun. And then looking at our OpenShift user interface, we can validate that the restore job has begun and is available within the UI as well. Okay, and we'll give it some time for the restore to complete. And once the restore does complete, we can describe the restore to see what objects and everything had been backed up or been restored as part of the restore process. And then we can do a Helm list, Helm application. We're doing a Helm list again to get the details of the application, and we can go into the individual objects, the replica sets, the deployments, and everything to see that everything had been restored correctly. And putting rubber to the road, we'll expose the application and make sure that our data that we had earlier is available for us to use again. Then finally, we can validate everything on the OpenShift user interface as well, making sure that your application has been successfully backed up and restored into the restored NS namespace. Okay, so with that, I am going to share my screen again. Just to confirm everyone can see my screen. Good to go, move forward. Okay. Next, I'm going to talk about compatibility and support of TrilioVault for Kubernetes. So from a compatibility perspective, as we mentioned, we have tuned the product to work for at OpenShift and for upstream Kubernetes. So if you're using it for test and dev purposes, you would want to use at OpenShift 4.1 to 4.3, or if it's upstream Kubernetes, that would be upstream Kubernetes 1.12 to 1.16. The reason why we're calling this as test dev is because the CSI snapshot functionality that we leverage is still in alpha stage up to 1.16, and it becomes beta in 1.17. And there is backwards compatibility that is generally expected between beta versions of a particular API. So, which is why we are suggesting to use 4.4 or 1.17 plus for prod environments. From a storage perspective, as long as your storage supports CSI, you will be able to use TrilioVault for Kubernetes without any issues. From a target perspective, we mentioned you can use Amazon S3 as a target, or any S3 compatible storage, or any file-based storage based on NFS as well. Ecosystem tooling, we spoke about integration with Grafana, Prometheus, and Fluentd, and we get all these out of the box. And now, because we've built this native to Kubernetes, native to OpenShift, you can run this anywhere you have an upstream Kubernetes environment, or you have an OpenShift, fully managed environment, or a fully unmanaged environment, wherever you want to run it. Okay, with that, I will jump into the summary. So what we've explained today, what we have gone over today, is that first thing, traditional approaches or traditional data protection solutions are not satisfying cloud native application requirements. TrilioVault is a purpose-built product which has been developed as an operator to protect cloud native applications, which can be based on Helm, operators, or custom labels. The entire product is Kubernetes native. We have ecosystem fluidity by integrating into all the de facto tools that people use in a Kubernetes environment. And then finally, we have a plethora of use cases that are built on top of backup and restore, which enable you to do point-in-time data protection, disaster recovery, data management of your applications, or just plain migrations as well. It's a mature product, or we've been around doing the data protection pieces for a while. As I mentioned, we have been the leaders for other data protection solutions, and we are bringing all of that intelligence to the Kubernetes realm as well. And for all of you, the next thing to do would be to get to our website, that is trilio.io. You guys can watch a demo of the product as to how we are doing backups and restores for labels, Helm, operator-based applications. You can try them out yourselves. You can use the live scenarios directly from the website, and then you can download a free trial or a basic edition in your environment directly from the operator hub and try out the product and ensure that it meets your needs. With that, I conclude my presentation with the content that I had, and I believe we have about 10 to 12 minutes, and I can take questions at this time.
Yeah, we've gotten a bunch of questions in so far, but there is still time. If you have a question, go ahead and use your GoToWebinar control panel and submit it. And why don't we just go ahead and dive right on into them. Here's the first one. How deep can you go in terms of RBAC for TBK?
So one of the things that we've done is all the CRDs that I was showing earlier, all those CRDs are RBAC enabled. So you can actually segment your segment the technology in such a way that you could have your admins creating the backup plans, and your developers or your users only having to or being able to create backups, but not being able to define the backup plan, or vice versa. Or for example, you may want to keep the target storage in admin control, but you would want all your developers to back up into the target. So all those pieces and all those use cases are possible as well.
All right, great. Next question. How do the hooks work for TrilioVault for Kubernetes?
How do the hooks work? So basically, we have two methodologies on how we do this, right? So you can either have custom commands injected into the container if the environment allows that, or you also have the ability to inject commands via REST calls. So we provide a REST interface within our hooks CR. So that users can connect to the database and execute a REST call that would, QS on QS the application in general.
All right, great. Next question. Do you support deduplication?
So one of the advantages of using the QCOW2 image that we leverage is it's very, it's parse friendly. It enables software level deduplication by only copying the unique blocks and enabling, actual deduplication on the application that you have been backing up. So as a result, what happens is the amount of data that you store on the target storage is less, and also the amount of data that you're pushing over the wire is going to be less. So when you think about your targets being in public cloud or hyperscalers, you can think about the ingress egress charges of pushing data in and out. And using a technology which is efficient as such that we are providing is going to eliminate those costs for you out of the box.
All right, excellent. Next question. What is the lowest RPO that you support?
So today we support up to 1 hour, and we will be working towards reducing that RPO, but at the moment it is at 1 hour granularity.
All right, great.
Yeah.
Okay.
I do see a bunch of other questions.
Yep. I was just about to get to another one, but if you see one in there that you want to go ahead and take, feel free. But I can certainly ask you these questions as well.
Sure. So I think one of the first questions that I see, what are some examples of key differentiators of TrilioVault at scale versus alternate solutions provide backup recovery and metadata being run in hyper-converged infrastructure environments. So we touched upon the QCOW2 image and the ability to do software level deduplication. That's one. We support forever incrementals because of this technology, and from a scalability perspective, we do tout infinite scale as one of the features of our product. So I would definitely say from a scalability perspective, that is one of our key differentiators. Okay.
Great. Do you want me to go ahead, or do you want to?
Anything is fine, however you want to do it.
Okay, all right. So here's one. Can you describe the difference between deploy and migrate?
Deploy and migrate. Not sure if I get the context of deploy and migrate, but if I had to answer this, I'm assuming, I think I'll probably need some more color on this question, because if I had to just state it, it would probably be, deployment is basically what we end up deploying at deploy time, and migration would be something that we end up doing at runtime. That's the kind of differentiation that I see. I do see some other questions around can we restore the backup on a different Kubernetes instance? Yes, we can definitely restore the backup on a different Kubernetes instance. So what happens is the data is stored on a separate or a central repository, which could be S3 or NFS backed. And then from that central repository, as long as it has network capability to talk to any Kubernetes cluster, you can restore it onto that cluster.
Here's a good one that I see. In implementing your backup solutions, does one require the installation of SNMP agents on the targeted nodes or containers?
Nope, we do not require anything of that sort at the moment.
Okay, let's see. What is the storage needs capacity associated with large organizations, 500 plus applications, to ensure performance is maintained?
what is the storage needs capacity associated with large organization applications to ensure performance is maintained? I would say from a storage perspective, it is more of a strategy that large organizations would have to entertain or implement. It would be more on, kind of having different kinds of disk technologies to ensure, data that is being accessed more is placed on that fast-paced storage. Uh, having tiering policies of how, your data is being moved from fast tier to the slow tier to the slowest tier in terms of usage and in terms of demand and in terms of compliance. So I would say it is more of a strategy that large scale organizations would want to implement.
Okay, I think we have time for one or two more questions here. Here's a good one. Do you just currently support AWS S3, or is it valid for any S3, Wasabi, RH, SEP, Zadara, etc.?
We support any S3 storage. So whether it is AWS S3 or any S3 compatible storage, we will be able to support it. I do see some other questions around is the data backup encrypted? So we do not have data encryption. We do not do data at rest encryption, so that we are letting the storage vendors provide encryption capabilities, but you can expect that as a future roadmap item as well. The other question, are there security policy settings in the security module? Yes, we have documented each and every capability for each and every pod of ours in the security module that you can find. We also call out where the pods are being, coming into play, whether it's at deploy time or runtime, so that security admins can apply the correct policies accordingly.
Okay, I think we have time for one more question. Are there standard audit reports from the Vault monitoring and logging component?
So while there are no standard reports that we provide, Grafana people have been using that to create a lot of auditing reports, and users and customers can actually leverage the pre-created dashboards that we have built to generate audit reports and just audit reports and general monitoring information that they can circulate within the organization for compliance purposes.
All right, great. I think we have time for one more quick question. This should be useful for stateful applications. Any use cases for stateless applications?
So this is a thing that we've been kind of going over, within the data protection community for a while now. When we generally talk about stateful, we talk about having the application and data. But when you think about stateless application, generally you don't have data associated with a stateless application. But what happens is, when you're running a stateless application, you could two scenarios. Either it's an independent stateless app, but it still has that metadata associated with that application, which needs to be protected in terms of, okay, hey, what security context is the stateless app running in? What are the other pieces that it's connected to, or what other storage classes, volume snapshot classes, or anything that it may be using on the existing platform? What are the secrets, services that stateless app may be leveraging as part of its operation? So that those pieces still need to be protected, right? And whether in terms of an application definition, you could still have stateless components talking to stateful components. But when you zoom out and you take a look at the application, you'll have stateless components talking to stateful all over the place. But that entire application needs to be protected as one unit. You cannot leave the stateful piece behind. You cannot leave the stateless piece behind. So as a result, this becomes something that you would end up using not only for stateless applications, but for stateful applications as well.
Okay, all right. Well, we are about 2 minutes to the top of the hour, so unfortunately we do have to close out the question and answer period. I do want to thank everybody who did submit questions, and if we didn't get to your questions, please know that the folks at Trilio are getting a copy of all of the questions that came in, and I'm sure they'll be more than happy to follow up with you offline. Also want to remind the audience that today's event has been recorded, so if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. following today's webinar, we are sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the DevOps.com website, so you can find it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, real quick, let's go ahead and do the drawing for the four $25 Amazon gift card winners. Our first winner today is Chris B. Congratulations, Chris. Second winner, Jim B. Congratulations, Jim. Third winner is Paulo P. Congratulations, Paulo. And our final winner today is Sharon S. Congratulations, Sharon. Guys, check your inbox. The information regarding your gift card should be there waiting for you. Prashanto, thank you very much for such a great presentation. Lots of really interesting stuff in there. So I appreciate your time, appreciate your expertise.
Thank you, Charlene. Yeah, happy to be here and spread the good news about this product. And yeah, if folks have follow-up questions, feel free to reach out to the Trilio team. My Twitter handle is on the screen, so feel free to reach out via Twitter or via email directly.
Okay, great. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.